First, we'll hear from Thomas Isakovich, who's CEO and founder of Nimbus Data. Thomas Isakovich is CEO and founder of Nimbus Data, which produces scalable flash arrays with multi-petabyte capacity. The company's exaflash arrays, announced at this conference this week, support scalable workloads for cloud, big data, virtualized resources, and digital content. Before starting Nimbus Data, he was CEO of TrueSAN Networks, which focused on storage virtualization and multi-vendor SAN management software. As a brief reading of his CV reveals, he has never followed the traditional path. As a youth, he designed and built his own high-capacity disk storage system to increase the amount of storage he had for video editing. In recent years, he oversaw a complete redesign of the company's products to take advantage of new technologies such as flash at scale. And finally, in his leisure time, he likes to surf in the ocean and jokes that he would like to have more board meetings by the sea with business associates. So please join me in welcoming Thomas Isakovich.
Thank you, Gene. Thank you. All right. Well, good morning, everyone. My name is Thomas Isakovich. Thanks for that great introduction. Before I get started talking about the topic for today, I did want to take a moment to absolutely congratulate and thank the organizers of the Flash Memory Summit, and not just for putting on a great event that's grown 20% year over year, which is awesome, but as someone who loves to innovate and loves to dream big, walking around the show floor and seeing all the different technologies and the way the industry is moving forward, I think it's really helped inspire new development in Flash. Frankly, I think the Flash market has probably grown 15 or 20% faster than it otherwise would have because of Flash Memory Summit. So I'm just thrilled to be working with this organization. They're such a great group, and I just can't, pound the table enough virtually with words about everything I think that's this community has put together. So big round of applause for the team here at Flash Memory Summit. And with that, let me go ahead and get started on what we're going to be talking about. So as the title of the presentation here shows, we're going to talk about how you scale Flash effectively and efficiently in an era when companies want to deploy huge amounts of capacity. When I started this company back in 2006, our first product was a 2.5 terabyte all-flash array. And I remember at the time, most SSDs were 8 gigabytes or 16 gigabytes, and 2.5 terabytes sounded like all the flash in the world. You're never going to need more than that. And at the show floor today, we're showing an all-flash array that's 4.5 petabytes of flash in a single box. So in 10 years, we've managed to innovate a million times over this technology, and it's really, really fascinating. But we're one of the early guys in this space looking at flash, not on a component level or an SSD level, but really looking at it on a system level. The company is privately held. We funded the company with a handful of investors and have basically been growing the company off of our own success, our own customer wins. We never took any venture capital money. And the cool side of that, other than not having so many traditional board meetings, but having more so-called board meetings in the ocean, is that you really get to think freely about long-term and just building the best technology, which has been a lot of fun. So the product we announced at the show here we call exaflash. And as the name suggests, we're looking at how to scale flash to the exabyte era. Now, in terms of our customers, they're some of the biggest data consumers that are out there. It includes companies like eBay, Disney, DreamWorks, Lockheed Martin, and a certain large company named after a fruit that makes devices that go in your pocket. So when we look at the evolution of all-flash arrays, as I mentioned, back in 2006 when this all got started, it was really all about speed. People were using SLC flash. They didn't really care about features. They cared about latency. And everyone knew it was going to be expensive. And capacity wasn't that high, but it met a need for a very specific use case for, say, accelerating databases or accelerating logs. And over the next 3-4 years, MLC flash became more reliable, And dedupe and compression technology was introduced, and that allowed customers to build systems with bigger capacity. The market's bigger. The performance wasn't quite as good, but it was still good enough. What we see is that we're really on the cusp of the next wave of flash adoption. And you've heard a lot of talk about the all-flash data center, and what may be necessary to pull that off includes some things like having a system that's completely API-driven, having a system that maximizes efficiency in terms of power and space, having a system that's inexpensive relative to traditional flash arrays, meaning taking out the $1 per gig price barrier, and then being able to, of course, build systems of significant capacity, petabytes and more. So how do you do this? How do you build an all-flash data center? Or just try to get close, because right now a data center is probably only 5 or 6% flash. Well, the first question is, goodness, how are you going to afford it? Flash is really expensive. How's anyone going to afford this? Second question is, how are you going to scale it? How are you going to manage it? How are you going to manage an infrastructure at that size? And then an infrastructure at that size needs to be very flexible. So how are you going to handle different workloads? Some workloads like block storage, some like file storage. How are you going to handle all these different workloads together? How are you going to get power to this thing? How are you going to cool it? How are you going to handle the data center operations of it? And lastly, how the heck are you going to fit it? Data center racks are overflowing. How are you going to be able to deal with data growth and physically build this kind of a system? Well, I'd like to kind of take on these problems one at a time. And the first I'd like to talk about is cost. 2 years ago, I gave a talk here and looked at the cost of all flash arrays and wondered, why are they so expensive? Why are they so expensive when the flash is so inexpensive? And I didn't really give any clues as far as what we were going to do about it, but for the last 2 years, we've been working on doing something about it. This here shows basically the makeup of cost of an all-flash array. So obviously, you're going to have the flash itself. MLC flash, say 35 cents a gig. Then you're going to have the NAND controller, which sits inside the SSD, which is managing the flash. Well, those are around 35 cents per gig too. If you look at the typical cost of an enterprise SAS SSD, 35 cents plus 35 cents, 70 cents per gig. Yeah, that's close to what a traditional enterprise SAS SSD is going to cost. Then you have the array, the hardware, the software of the array. Traditional vendors are charging about $2 a gig there. Then you get into the cost of distribution, and this is something that people forget. The cost of distribution is really expensive. In an era when users are using more cloud and the cost of distribution effectively goes to zero, the storage industry continues to have a very expensive distribution channel. That consists of resellers. Well, they're going to make a nice discount, so they want about $1 a gig out of this. The distributor, they're providing credit, so they're going to want about 30 cents a gig. And then the sales team that sold the product or deployed it, the sales engineers and so on, well, they need to earn a living too, so they're going to get around 15 cents a gig. So by the time you add this all up, you're over $4 a gig on a raw basis on an all-flash array. And vendors will come out and they'll say, well, you know, we can get you to $1 or $1.02 per gig, but it always means after deduplication or compression or some kind of way to extend that usable capacity. On a raw basis, this is about where it's at. So this, of course, is a problem to adoption, because at $4 plus a gig, that's significantly more expensive than hard drives. How are we going to build an all-flash data center? Who's going to build an all-flash data center if it's still that much more expensive than hard drives? So we kind of went through each one of these one by one and sort of took an axe to them with the goal of building a true hard drive alternative on a system scale using flash. So we went out and we built a fab. No, we did not build our own fab. So we still have to pay 35 cents a gig for chips. Can't do anything about that. We're not going to build a fab. But we're going to multi-source so that we can be competitive, as cost competitive as possible. We're going to do our own technology around the NAND controller so that we're not paying the SSD premium. That's going to take 35 cents a gig out of the cost. We're also going to design our own hardware and design our own software at a system level and be much more reasonable about what that technology costs because we're going to stuff so much more flash in there that we can prorate that cost over more capacity. And that's going to get us to a lower cost per gig in terms of the flash. And lastly, we're going to avoid the traditional storage distribution approach. We're not going to use resellers. We're not going to use distributors. We're going to sell direct, because the big buyers of flash, the companies that are really building data centers, they want to work direct with the systems vendor. They have a level of sophistication and know-how that allows them to do that. And of course, the sales team is still going to make money, but proportionally, they're going to make the same money, but it's less money in hard dollars because the overall cost of the system is a lot less. So after we do all of this, we end up with an all-flash array that from Nimbus Data is anywhere from 95 cents per gig on the most expensive side, our smallest capacity systems, all the way down to 50 cents per gig for our largest capacity systems. And this is sure to raise quite a few eyebrows, because effectively we're saying that an all-flash array with all the trimmings, hardware, redundancy, software that can do all the features you want, actually can cost less per gigabyte than just an SSD by itself. So this is what we're showing here at the Flash Memory Summit, and we think this is going to help enable the all-flash data center. Really, at the end of the day, cost is a huge factor. So then I talked about some other challenges, like how do you scale it? How do you manage it? With this ExaFlash platform, we've introduced new technology in our architecture that's not scale up, it's not scale out. It's a different approach. It's an ExaFlash approach that allows us to centralize management, yet provide virtually infinite scalability. And I'll talk a little bit more about that. We've also provided an API-based approach to management. Think about it. If you've got petabytes of flash and you need to go and create 1,000 or 10,000 LUNs, you're not going to point and click your way through a web GUI to do it. You're going to automate it through some kind of API, some kind of programming interface. So we're providing that with this product. I also mentioned that it needs to be versatile. It needs to handle block storage, file storage, object storage centrally. So our software provides for that capability so that you can consolidate all these protocols under one platform. It also needs to be incredibly efficient. Flash is super efficient, yet you wouldn't get the feel of that if you look at most all-flash arrays, which only have maybe 10 or 20% power efficiency advantages over hard drive arrays. And you wonder why. How's that possible? Well, it's because most vendors out there doing all-flash arrays are stuffing generic SSDs inside generic servers. They're not building a system with the mindset of looking at the unique needs of flash. So what we've done is we've done that, and it's allowed us to get about 95% energy savings relative to off-the-shelf hardware-based all-flash arrays, as well as significantly greater density. So we can answer the question of how do we fit it all? Well, we're going to fit it all because we can fit 50 times as much in the same amount of space as has been traditionally possible. I already talked about how we're going to reduce the upfront cost, but we're also going to reduce the ongoing cost through power, space, and cooling savings, and we believe those savings are about 90%. So I mentioned that we're not scale up and we're not scale out, so what are we? Well, let me just spend a minute talking about some of the downsides we see with scale up and scale out. The first is that both of these architectures were designed when the world was all about hard drives. Processors were fast, storage was slow. So that was the mindset when scale up and scale out were invented. Scale up, the problem with scale up with flash is as you add more flash, you don't add more processing power to the controllers. And that prevents the performance from increasing. In fact, it reduces the effective performance per gigabyte as you grow. Not good. Scale out is supposed to solve this by putting flash and compute together in a single box and then scaling across boxes. Makes sense. Scale out was invented for NAS when people wanted to build big single namespace NAS servers, and they couldn't stick too many hard drives in the same NFS box, so they had to scale across boxes. Why not apply this architecture to flash? Certainly several vendors have done so, EMC and NetApp among them. The problem with this architecture is that it eliminates or, frankly, seriously diminishes, at the very least, the latency and power efficiency and density advantages of flash, because you have to now stripe data across nodes. And the performance of the whole solution will be gated by the performance of the network across which the data is being striped. Even if you use a very high performance network, you have to go through multiple layers of physical hardware, multiple layers of operating system code to get to the data when you go across boxes. It's not necessary if everything was contained in one box. So you lose latency. And if you read the data sheets of these scale-out architectures very clearly, you'll see they're awfully nebulous about what their latency is at scale for good reason. It's horrible. It dramatically increases as they scale. The other problem is that it's very inefficient. To stripe data across nodes like that, you need a lot of CPU horsepower just to stripe the data. You also need to add additional levels of redundancy through data mirroring to compensate. So your usable capacity of the flash is seriously compromised. The other problem with scale out is it gets really risky when you start scaling big, because all of the nodes are dependent on each other. So if you had a cataclysmic event like a metadata corruption or multiple nodes failing simultaneously, the entire thing comes crumbling down. So you have a very large blast radius, as they say, or your failure domain is very, very large with scale out. So while the scale out vendors will talk about how they can scale to hundreds of nodes, the largest scale out all flash array I'm aware of is only about a dozen nodes. And there have been multiple circumstances documented of scale out arrays literally losing all their data due to metadata corruption. The entry point as well for scale out is pricier. You need to have a minimum number of nodes. So that's going to increase the entry cost. And because of the way the data is being striped across nodes, none of the scale-out arrays today support multiple protocols simultaneously, which means you're going to have islands of storage instead of one uniform pool of storage that can do block and file together. So what we did with our architecture is to look at the real benefit of scale-out, yet avoid all of these drawbacks. And what we basically determined was two things. If you could centralize management, you would solve about 95% of what people like about scale-out. They just want one pane of glass, one interface with which to manage their infrastructure. They don't want to be going to multiple boxes to try to manage everything. And the second thing is build a bigger box. If you could build a box that could hold hundreds of terabytes or even petabytes, you wouldn't need to scale out, because you wouldn't be confined in terms of capacity. You would be able to fit all the data you need in that single platform. So with our approach, we decouple the data flow and management. We scale out the management so you get central single point of control, but we do not scale out the data path, which means there's no data fabric, there's no interdependency between the nodes. This also gives the benefit of maintaining reliability as you scale, because you're not creating a situation where multiple failures can bring the entire cluster down. If you lose an array, you're simply losing that portion of the cluster, not the entire thing. It also gives you consistent performance. So your latency will not degrade over time. It'll stay the same as you grow. And because you're not having to stripe data across all of these nodes, your CPU requirements are dramatically less, which means you can replace that CPU with more flash and build bigger nodes. And lastly, this design allows for multiple protocols to be hosted simultaneously, so you're not going to have the islands like you would with a conventional scale-out approach. So this is the basic view of our topology. You'll have a pool of exaflash arrays. You can start with one and grow to n number of arrays. You'll have an out-of-band Ethernet network, which allows for management of all these arrays. And on that network, you'll have a virtual machine running our software, which consolidates the management across the entire cluster. And then you'll have your storage network, which can be Ethernet, fiber channel, or InfiniBand. And your servers are going to connect to that storage network along with our arrays, and they're going to have direct access to data. There's no data communication between the exaflash arrays themselves, only between the exaflash arrays and your servers and the management appliance, which operates out of band. So a big part of doing this is building a sufficiently large array. Because if you take, let's say, a 2U server which may have, say, 16 2.5-inch drive slots, even if you put in the latest and greatest 15 terabyte SSDs, maybe you're constrained to around 300 terabytes of raw capacity, which is quite a bit, but not enough to meet the needs of these large customers. So what we've done is we've built a hardware platform, a series of them, from the ground up that focus on power efficiency and density. We have 4 sizes to choose from. We have, on the low end, a 50 terabyte system. On the high end, we have a system that packs 4.5 petabytes of raw flash in a single 4U, fully redundant system. We're showing all of this in our booth, so definitely welcome you to check it out. Each array is fully redundant, so you don't need to achieve any additional redundancy by striping across nodes. Every array by itself is already redundant. And you have your choice of Ethernet, Fiber Channel, or InfiniBand networking, so you can provide for multi-protocol access. So just a quick rundown on the features that we have. Our A-Series, that's our entry-level product, scales to around 300 terabytes of effective flash in a 2U form factor. Because of our business model structure of selling direct and our vertical integration of integrating flash with NAND controller, we're able to drive this at a price point that's very appealing, under $50,000 entry point. Next up is the B-Series, which is bigger, still a 2U, but it's deeper and provides for more flash capacity, actually up to a petabyte of flash capacity in a single system. And then we move on to the bigger stuff. C-Series, this is a 4U system which holds up to 3 petabytes of raw flash. Does so under 2,400 watts of power at 65 cents per gig raw, which with dedupe and compression works out to about 25 cents per gig effective. Now to put this in comparison, to do this with a scale-out all-flash array, and you can pick either one of the 2 vendors I named earlier who do scale-out all-flash arrays, you would need anywhere from 50 to 80 times more rack space, 50 to 80 times more power, 50 to 80 times more cooling capacity, and you need a budget that's at least 4 times bigger. So we think it's a pretty clear choice. At these price points, not only are we competing exceedingly well against other all-flash arrays, we're on par with branded HDD arrays from those big vendors. And we think that's going to be a big part of what drives us forward. And I don't mean to sound like an infomercial, but one more thing, we have a D-Series, it's even bigger, 4.5 petabytes in that same 4U form factor, even deeper. If you have a modern data center with fairly deep racks, you can fit this guy in here. Record-smashing density, power efficiency, and a cost point at just 50 cents per gigabyte raw, which works out to about 19 cents per gigabyte effective. So all these products at our booth, I would encourage you to come check it out. Of course, the hardware is not complete without the software. So our software, our operating system, provides for that API I was talking about that allows you to automate management throughout the entire environment. One pane of glass, multiple protocols, all happening centrally. We also provide for deduplication and for compression. We also do checksumming. Checksumming is very critical because systems of this size, regardless of how good the hardware is, will be susceptible statistically to silent data corruption. So checksumming is a must-have feature because it's going to repair that silent data corruption transparently. Users won't even know it's happening. And of course, it provides for extensive monitoring and data protection features. This diagram here just kind of gives a quick summary of the different features available in our operating system. This is all on our website, so I would encourage you to come check it out. So in summary, we're big believers in flash. We started with Flash Memory Summit a long time ago. We've been in the all-flash array business almost since the beginning of that entire industry back in 2006. Yet, for all the work the industry has done, only 6 or 7%, somewhere in that ballpark, of enterprise storage is flash. As an industry, we can do better. The whole world knows everything is going all to flash. That's where this is moving. But to do so, we have to have a scalable architecture, a cost-effective architecture, a power-efficient architecture, and a dense architecture. You do those things, And I think you're going to start seeing data centers en masse begin to rip out their spinning rust and go to flash. So that's what we're focusing on at Nimbus Data. And with that, we'll be at the booth the rest of the day. Thank you so much.